me quickly ask you, I hope everybody can maneuver on Moodle. Is there any issue? Can you all maneuver on Moodle? You know how to get information on Moodle. You can see all the information that I've shared on Moodle. If you have anybody that is still struggling, please, you can unmute and talk before we proceed. I hope you can see all the information that I've shared. If you have any issue, you can type on the chat. I hope everything is fine from your end. So quiet means that we are all fine in terms of how to get information on the Moodle learning management system. So quiet means that we are all fine. So let's go into the Moodle itself, into the Moodle. I'm talking about our Moodle, not the Moodle learning management system now itself. So you are welcome once again to Operations Management Techniques 4, and this is the module where we expose you, actually is a continuation of what you have learned in the Operations Management Techniques 2, 2 and 3. So now we want to go a bit advanced to learn more about the advanced decision-making techniques that you can use to arrive at an accurate decision tailored towards solving a decision-making problem in a manufacturing or service organization. So that is what this module is all about. But you are going to learn more about other decision-making techniques that you have not learned in your second year and in your third year, which is your Operations Management Techniques 2 and Operations Management Techniques 3. If you still remember in your Operations Management Techniques 2, you have been exposed or you have been taught decision-making modules like break-even analysis, like your decision analysis, your linear programming, your transportation and assignment models to some extent. But here you have also been taught integer programming to some extent. So here we are going to build on those basics, especially looking at looking at the case studies on all these kind of problems, and also looking at other new decision-making techniques like dynamic programming and some other programming like nonlinear programming. So we are going to see more techniques, and we are going to see how we can advance our knowledge on what we have already learned already, so that we are able to apply all these decision-making techniques that we have been taught in second year and third year, and the new ones we are going to learn now in practice. So that is the essence of this particular module. So in a snapshot, it's all about learning the advanced decision-making techniques that you can use to solve decision-making problems, whether in manufacturing, organization, if you are currently working. So some of these techniques that I'll be exposing you to would be applicable to you if you work in that kind of environment, depending on the nature of the problem, operational problem we are looking at. Then you'll be able to apply it if it talks to you. Or if you are working in service, some of the concepts your service organization, some of the concepts we're going to also talk about now could also be useful to you. So during the course of the lecture, I will be asking you whether some of these concepts are talking to you or you can really apply it. So that is what this particular module is all about. So let me quickly highlight this. Please make sure you don't miss. Let me start with correcting the confusion. It's a blending, this module is a blended learning model, because that is the way the department has structured it. But when we talk about blended learning, it doesn't mean that we are going to go to campus maybe often. So the way we have structured our blended learning, we have structured it in such a way that most of our classes, we are going to do them online, because we know that most of you are working. So most of the classes will be online. Please, Ofinse, thank you off your camera? So most of the class sessions will be online. Then we only have contact class sessions if need be. If maybe we all agree that maybe there's a need for us to meet because don't forget, this module is a mathematically inclined module. So sometimes you might feel you want it. I remember last year we didn't have such because everybody was happy the way we have really the way I've really taught the module, they were happy. and we take it slowly, so everybody was happy. So there was no need for us to even go to class to campus for contact class session. But if there's a need for that, maybe to get clarity on some of the concepts we are doing online, that is when we'll arrange that contact class session, then we go to campus to go and have that session. So it's a once-off thing in terms of going to class, going to campus for the class. So, but the other aspect that you would require to go to the campus, which is non-negotiable according to the department, is the assessment. There are some of the tests that we have to write on campus, because don't forget, this is a university which you're supposed to appear on campus to have the class session. So that part, according to the department, is non-negotiable, that at least for some of the assessment, even though we want to go online, we still need to have some of the assessment on campus. So take note of that. So you see, let me quickly run through the assessment quickly. For this module, this is a continuous assessment model. And at least that will tell you which assessment will be done on campus, which one will be done at home or online, so that you'll be able to prepare your mind for that. So it's a continuous assessment model, meaning that there is no exam for this particular model. Take note of that. There is no exam. And we are going to have 4 assessments. So the first assessment, if you go to the learning guide, is also well spelled out there. But just to echo what is important in this learner guide, so please, you can also read the learner guide at home. But if you go through it, you see that we've got assessment number 1. That is a closed book written test, which weighs 10%. It weighs 10%, and that test is written on campus. And we've got the second assessment, which is an online test. That online test, the way we've structured it, you can write it anywhere you want. If you like, you can write it on campus. If you like, you can write it at home. So it's up to you. And that one weighs 15%. And we've got the third assessment, which is a research-based assignment. That one weighs 30%, and that is the assignment where it's not a Google assignment. It's an assignment where you need to apply the concept, one of the concepts that I'm going to teach you in class, and you gather your own data, your own operational real-life data of your own choice within that domain stated in the assignment. Then you apply the techniques that I'm going to teach you to solve that decision-making problem. And that assignment is a group assignment. And the essence of the assignment is to ensure that you master the concept so that you know how to apply this concept in practice. Because most of us, we are very good in cramming. We can solve integer programming, we can solve linear programming, but if I ask you now to go and apply it in practice, you cannot do that. So hence, we want to move away from that. Hence, the reason why we are making that assignment to be a research-based assignment where you apply one of the concepts you are taught in practice. And in that case, you have confidence that you have learned something from this model. So, and that weighs 30% is a group assignment. So we'll talk about the group number, but most of the time is always 3 to 4 people in a group. But when we get to that bridge, we know how to cross it. We finalize the number of people that must be in the group. So that is the third assessment. And the fourth assessment is the summative test. And that is synonymous, actually, that is synonymous to your exam. That is really synonymous to your exam, but it's not the same thing as exam. So it weighs, I hope you can hear me. I'm back now. So I was just trying to switch because now the network is back. So that assignment, like I was saying, the last assessment is the summative test. It weighs 45%. And that assessment, it covers 70 to 80% of the module that we're going to do for the whole semester. And that particular assessment is also a written test which will be written on campus. So any question with respect to the blended learning, because I know some people are confused. Is it all clear now? Just type Y. Don't forget this is an online class. So the way I always try to, because we want to interact, even though we are not on campus, I can see you. So I always ask you to type Y on the chat just to see that you are following. So if everything is very clear in terms of the blended learning and the assessment that we're going to have there for the course, just type Y on the chat window, please. It's just to see that we are following and to see that we are still there. Can you type Y on the chat window if everything I've said so far is clear? Thank you, Tapelo. I'm waiting for other people to respond. Please don't be tired of typing Y. We need to communicate. If not, that means there's no teaching and learning. There's no interaction. Thank you. Thank you for that. Thank you. So don't be tired of typing Y. I just want to see whether you are still with me. So let me see. Temba, from your side, are you there? Nazia, from your side, please respond. I see most of the people have responded. Please respond. So I think it's fine. Most of the people have responded. So if you need any clarity, feel free to ask. You can unmute, raise up your hand, and I will see your hand being raised, and I would give you an opportunity. Then you can unmute and talk if you have any question. But so far from what I see, I see Brian. Brian, your hand is raised. Yes, over to you. You can unmute and talk.
I was trying to write on the chat. It doesn't give me access.
Doesn't give you access, but actually the option was given to you. Let's see, meeting options, because that was, I've set that to make sure that you have access to the chat, unless maybe there's issue with network from your end, because even myself, I experienced the same. But let me check the meeting option again if it shows me that information. I think from this side, I can see meeting chat, that information is there, is on. So maybe it's network from your side. It might be network from your side because it's on here according to what I have here. So maybe it's the network from your end. Can any other person also try to type on the chat? Does it allow you? Yes, Akiwe, over to you.
Just a quick question in terms of the times for the test that will be written on campus. Since there are people, I believe, who are working, are they going to accommodate people who go to work and only like um, get out of work at around 4?
No, the
Are the
way,
tests going to be in the evening, or one has
no,
to?
okay, it's fine. Let me allow you to finish. Sorry, I was
No,
thinking you were
you
done.
can continue.
Okay. No, the way the test is structured is because we want to accommodate everyone. That's the same thing we did last year. The test is during the class period, during from 6 to 8. It's always a
Okay.
2 hours test, especially for the first test, which is 10%. So it's from 6 because we know you are working. So we need to design our assessment time in such a way that it accommodates all of us, not to inconvenience us.
Mm-hmm.
Does
Sounds
that
good.
make
Thank
sense?
you. Yeah.
Yeah. Any other question? Any other question? I think, Brian, I think it might be problem from your end because I've checked the settings here. Let me just take it back to on again and just click save. Maybe it would allow you, but everything is set to be proper. So, but if you cannot maybe type on the chat, please feel free. Just raise up your hand and I'll give you an opportunity to talk. Feel free to engage. That's the reason why you're in class. So I think with that being said, let's move right along. Any other, I think everybody is fine now. Let me quickly take you through the modules, or the topics that we're going to do in this model. So like I said, this is Operations Management Techniques 4. Is the continuation of the Operations Management Techniques 2 and 3. So the modules which we are going to cover here, which is Operations Management Techniques 4A, I won't go through everything in the learner guide, but I'm just highlighting what is important. So please, when you have time, go through the learner guide. If you have any question with respect to any information captured in the learner guide, you can send me an email. My email address is also there. So you can send me an email then I will come back to you. Then also, let me also quickly highlight this. In terms of the consultation time, don't forget this module is highly mathematical in nature. And you see when we start now, because today we'll just try to start a bit because we don't have time. Time is not really on our side. Time is flying. So we'll start to introduce the first module today to some extent, start with the first concept, then we continue next week. So I think today we might not get to 9 p.m. So we might finish the class around 8 or so at the latest, because I don't want the first class to be very hectic. I still want to welcome you to say, look, we are together. But from next week, don't forget it's a mathematically inclined module. You need to be around. We use all the hours because when you are dealing with mathematically inclined modules, it requires a lot of time and we need to take it slowly so that you understand the concept. It doesn't make sense for me to rush it, then you get confused. So it's better to take it slowly. Then if you have need any clarity, you ask. Then from there, I can clarify so that at least at the end of the day, we master all the concepts. And let me also say this, all the sessions will be recorded. All the sessions will be recorded. All the sessions will be recorded. So, and after the class, maybe a day after the class at the latest, you'll get the link on how to access the recording so that you can, if you want to watch the recording again, maybe you need any clarity, or you want to use it to study in preparation for forthcoming assessment, you can always go to the link, replay the recording, play it slowly, listen to it slowly, and also replay until you are very happy that you have mastered the concept. So take note of that also. And let me also plead with you. The fact that we are also recording the session, it doesn't mean that you must miss the session. This is not a theory module. It's not a theory module. This is a mathematically inclined module. So if you are missing class sessions, I think you might find the recording is there. You can go and listen to me. If you are very, very good in mathematics, maybe after listening 2-3 times to the recording, you can quickly catch up. But if you know that your mathematics, you are still trying to get there, I'm pleading with you, don't miss sessions. Don't miss any of the class session. Avail yourself. Avail yourself for all the classes so that when I'm doing those mathematical concepts of mine, then you are able to see how I'm doing it. If you need any clarity, you're able to ask me questions. Then I'm able to clarify to you on spot. Then in that case, you get everything clear. But don't forget, if you're listening to recording, if you get confused, who do you call? It's because it's not a real-time class. You're just replaying the session. So please, I'm begging you, don't miss class sessions. However, maybe if you're sick and you miss sessions, go through the recorded class sessions and engage also one of your class members that are in class. Maybe if you need any clarity to help you. Then after engaging them, if you still need any clarity, you can arrange for a consultation. Send me an email indicating which aspect is not clear, then we can arrange a consultation session. And my consultation time is every Monday from 2 p.m. to 4 p.m. Every Monday from 2 p.m. to 4 p.m. So please try to avail yourself during that period if you need any clarity on any aspect that I'm going to be teaching. Please take note of that. But I think if you ask those people that completed this module last year, they all enjoyed it if you're in class. So it will be very straightforward and you enjoy it. So please, I'm begging you, don't miss any of the class session. That's why I'm trying to repeat it several times. So then I think with that being said, let me just also upload the learner guide. Let me just share the learner guide quickly with you. It's just to show you what you have on Moodle. So actually, if you go to Moodle, there's something like click here to download the learner guide. If you click here, then you'll be able to get this learner guide. It downloads it for you. Then you're able to see my details. Then you can see everything that I'm talking about so far. Here, the assessment and the modules we're going to cover for operations management techniques 4A and operations management techniques 4B, which will be in second semester. So this is what you must see if you go through it, but I'm not going to go through it so you can read it when you get home. I hope you can see what I'm sharing. Please confirm. Type Y on the chat window. Can you see it? Can you see what I'm sharing? Thank you. Thank you, thank you, thank you, Sakiwe. Thank you, thank you, thank you, everyone. Thank you, Temba. Thank you. Good. So please make sure you go through that. I hope that makes some sense to you. Thank you very much. So I think with that being said, please go through the learner guide and make sure you are all sharp. If you have any question, please feel free to ask. So let me quickly highlight what are the modules that we are going to cover. Then from there, like I said, I won't keep you long today. It's just to welcome you, but we need to start. And let me quickly highlight this, lest I forget. Our first test is coming up around, let me just quickly show you on the learner guide. Tentatively for now, our first test, if you go to, because these are just tentative dates, but we'll confirm it when we get closer to that date, depending on the availability of venues and some other logistical issues that we need to sort out in the department. So I'll quickly show you. So tentatively for now, our first assessment is on the 21st of March. So you see it's around the corner. So that means as soon as you start today, please don't leave anything I teach you to say you are going to leave it till around a week before the test. It won't help you. You are going to mess it up. So if you want to get a distinction, you can ask those people that passed this model last year. If you follow my instruction, you will never get it wrong. When I teach you a concept, that day I always give you exercises to do. Make sure you practice those exercises. And also, lest I forget, like what we did last year and everybody was happy, try to work in groups. You can form a group of maybe 3 people or 4 people, is up to you. So that you can, when I give you those tutorial questions, you can do those assignments individually, and that group that you form, you can share your answers and engage, or you can even solve those questions together. And don't forget, 2 heads are better than 1. Then as soon as you finish solving those tutorial questions, the group leader, you can have a group leader who will now, you can make scan your solution and send it to me to say, this is the solution of our group. Please, Dr. Makinde, can you check our solution to confirm whether our solution to those tutorial questions are correct? Then I will check those, your solution. Then I will advise where there are mistakes. And let me quickly highlight this, because this is what happened last year. Most of the students always think, no, we need to provide memorandum. We don't do that. Memorandum is not given for the tutorial questions. The essence, because when we give you memorandum, we've realized in the department that as soon as you have memorandum, then you are not practicing. You go and cram the memorandum. Then when you see similar question in the test, because you have not practiced it, you see a new question which is synonymous to what you have done in the tutorial, because you didn't do it yourself, because mathematics is a ministry of doing it yourself. Then you start panicking, then you mess everything up. So please take note of that. There is no memorandum for tutorial questions. You must do the tutorial question as a group, like I was advising, and the group leader send me the solution to those tutorial questions. I will go through. If there are mistakes, I will correct you. And that is how you can learn, because you have already got involved. So when you realize where your mistakes are, you will never forget. Unlike just having solution, you cram it, you see a new question, which is synonymous to what you see in the tutorial questions, because you didn't do it yourself. Then you start struggling. So you understand the reason why now we don't want to give memorandum. Please take note of that. It's also for your sake, so that you can do very well in the module. So take note of that. So I think I've highlighted most of the things. So like I was saying, the test one tentative for now is the 21st of March. So it means that we need to start at least to some extent today, because March is around the corner. We don't have a choice. So hence we start the first module to some extent today. We look at one concept, then we continue fully next week. So I think with that being said, let's move on. Let's quickly talk about the topics that we're going to do for this module. So the topics we are going to do for this module, please, if you have a pen, you can write it down. It's also there in the learner guide. If you want to, if you go through the work schedule in the learner guide, you can see all the learning objectives for each of the topics we're supposed to do, and the topics and how we plan to work for the whole semester. Everything is highlighted in our work lecturing schedule. So you can go through that. So let me quickly also highlight the first topic. If you want to, I can also type it on the chat window for you. The first topic, topic one. Topic one, we are going to be looking at transportation problems. And I know you have done transportation problems before. But we want to build on that because you did transportation problem in your second year operations management techniques 2, and you were introduced to that concept, but we want to see if you have a real life transportation problem, if you're a logistics officer or transportation planner for a particular manufacturing organization, how do you deal with this kind of problem when you have series of maybe you have got series of supply base and series of customers staying in various locations. How should you ship product from various supplier bases to various customers so that at the end of the day, you're able to minimize the cost of shipping the product? So that is what that particular topic look at if you are employed as a logistics officer or transportation planner. So we are dealing with that first topic, topic 1, transportation problems. Then topic number 2, we are going to be looking at deterministic dynamic programming problems, deterministic dynamic programming. That's topic 2. I hope you can see what I'm typing on the chat. Then topic number 3, we are going to look at probabilistic dynamic programming. Then topic number 4, we are going to be looking at deterministic inventory models. I think those people that are working in the inventory environment, where you are dealing with managing inventory for your organization in terms of sourcing items that are required in the organization, maybe this will really interest you. Then you learn a lot from this model, then you can see how to apply deterministic inventory models. So that is topic number 4. Then topic number 5, probabilistic. Don't be worried and carried away by the English. We'll break it down nicely. Don't worry. It's not difficult. Probabilistic inventory models. And the last topic, because we want to equip you, want to be you to be armed with the relevant knowledge to make you a good decision scientist. Network models. So those are the 6 topics that we're going to be covering. So let me quickly highlight again, why are we doing this models? So like I said, we know most of you, if you are not even employed, most of you in the nearest future, you want to apply for example, with the first topic, transportation problem, you might want to be applying for a job as a transportation planner or transportation officer or logistics officer. So for you to be able to excel in that work environment, you really need to master this concept because you will be dealing with shipping products, looking at how best to ship product that you have produced or you have in your organization to various customers sitting at various locations. And it could even be a big organization where you've got different supply bases for all your materials and you need to ship to various customers. Then how best should you ship your product from various supply bases to various customers staying at various locations, so that at the end of the day, you are able to minimize the cost of shipping the product. And if you minimize the cost, then definitely the organization will be getting maximum profit. So that is what that first topic is looking at, which you did in second year, but we are going to build on what you learned on second year. I know some of you didn't do operations because you are coming from other discipline. Hence, we are also going to do another example just to take it slowly with you and show you how we form transportation problem, how we solve it, because we know some of you didn't do operations management as your first degree. Maybe your diploma is not operations or your first degree is not operations. So we'll try to do some examples so that we show you slowly. Then you can catch up. So take note of that. So I'm aware of that. So please take note of that. Then at least after you finish that particular module, we expect that at least you have that knowledge to make you a good logistics officer, a good transportation scheduler or planner. So take note of that. And for those people that are working in that environment already, maybe in the transportation department or shipping department, so you be in a position or you are working in the logistics department, then you'll be able to apply this concept I'm going to teach you to properly plan how you're supposed to ship. And if you're already doing it, you can see that at least what you are doing is making sense. So that is topic one. Then topic number two, which is deterministic dynamic programming. Here we are going to be looking at how do we, when we talk about dynamic programming, for those people that did operations management techniques 2, 3, and 4, 2, 3, and 2 and 3, sorry, because we are now in 4. You remember in your second year, you have been exposed to linear programming. You have been exposed to integer programming. That's, I think I still remember very well. Even to some extent, you are exposed to Go programming, which we're going to go a bit now deeper in terms of application when we get to second semester, so that you can master this concept very well. So what are all this programming all about? If you still remember, for those people that didn't do maybe operations management for first degree as their first degree, when we talk about all this programming of a thing, don't be carried away. We are not really, because some people are already worried to say, are we going to be coding here? Are we going to be doing, are we computer scientists? Are we going to be writing codes? Not really. When we talk about the programming there, it's all about generating some set of mathematical iterations to solve an operational problem. So that is what the programming means. So we are going to build on the existing knowledge of your linear programming and dynamic and integer programming to be able to see how can we solve more operational problem. And all these programming, let me also say this to you, whether it's linear programming or integer programming or Go programming, what are they trying to do? Because I think most of you are just doing those mathematics then, but you don't know why you are doing those. But just for you to know now, the essence of all this programming, including this deterministic dynamic programming, topic 2 and topic 3, the essence of all of them, anything that talks to programming, operations management techniques, whether it's 2, 3, or 4, it's all about you trying to what? Utilize your resources effectively. Think about it. It's all about optimal usage of what? Resources. And if you still remember, for example, let me just quickly give you an example of what you did in your second year. And maybe people that are also not part of they didn't do operations, at least you can use this to relate what we're going to talk about. Think about it. You are the operations manager in a particular organization. You are the operations manager in a particular manufacturing organization, and you are producing 5 products. You are producing 5 products. And that 5 products that you are producing, think about it, the demand for each of these products will differ. So you might have get maybe the different demand quantity for each of these products, or you have forecasted based on historical data, what is your predicted demand for those products. So, and don't forget, you have different demand for maybe 5 products, and the resources you have, don't forget they are limited. Resources might be talking about the machines. It might be talking about the workers. It might even be talking about the capacity you have to store your raw materials to produce the product. And you have also asked yourself, don't forget I have limited resources, and I need to meet this demand quantity for each of these products. So the question is, how best should I allocate my raw materials to produce which product, and how many should I produce? So that at the end of the day, I'm able to minimize the cost of meeting those demand requirements from the customers for those 5 products, and I'm able to maximize the profit. So when you deal with those kind of problems, then you have to use any of this kind of programming, because it's all about the resource allocation. How best should I allocate my resources? So that is what all this programming they have been doing from second year has been looking at. And that's why you are busy formulating the linear programming model or the integer programming model, then trying to solve it to get a solution that will advise you how best you're supposed to, how many units of each of the products should you produce. So I'm saying this so that those people that are cramming even in second year and third year, you now can relate why you are doing those mathematical jargons that you did then. If what I'm saying makes sense to you up to this far, just type Y on the chat window. Because I know I say a lot of things, but I always want to check in between. If what I've said so far makes sense, type Y on the chat window. If you have questions, feel free to ask. Please, I want everyone to respond, please. No Lutando, please. I need, thank you. Good. Thank you very much. Thanks. So that is what all this program is all about. So this interesting topic 2 that we are going to be doing is going to look at dynamic programming, and it's a new kind of programming that you have not done. And what does that kind of problem look at? It looks at, we are going to see some examples of resource allocation in, maybe think about a production planning and scheduling problem. Think about it, the demand for various kind of products in a particular organization, like I told you, on a weekly basis or monthly basis might differ. So how best should I produce so that I minimize the element of overstocking product, because overproduction is a waste. If you still remember from lean manufacturing that you are taught in operations management 4 or operations management 2. How should I produce in such a way that I'm able to minimize the cost and I don't run out of stock for what is required by the customers? So when you deal with short-term production planning and scheduling problem, we are going to see how do you use deterministic dynamic programming to solve it. Then the third one, which is topic 3, is probabilistic dynamic programming. The difference between deterministic and probabilistic there is when you look at topic 2, where you are dealing with topic 2 in terms of deterministic, it means that information in relation to that operation problem is known with certainty. That's why it's deterministic. For example, you know with certainty what is the demand for each product. If, for example, customer has already ordered to say, look, I need exactly this number of products. So they have pre-ordered for that number of products. That means in that case, those the parameters, the operational parameter for that problem is known with certainty. So if you are dealing with a problem where all the operational parameters for that decision-making problem is known with certainty, and you want to know how best to allocate resources to be able to meet those demand requirements, then you must be using the deterministic dynamic programming approach to solve that production planning and scheduling problem. But if we get to topic 3, which is probabilistic dynamic programming, it means that the parameters in that operational problem is not known with certainty. A very good example, let me take you to ShopRite. A very good example is, think about it, if you're the operations manager in ShopRite, or you are the inventory control manager in ShopRite, you don't know with certainty. Look at all the items on the store. Do you know with certainty how many bags of rice would people buy, maybe of 2 kg? You don't know with certainty, because the demand for 2 bags of rice on daily basis differ. You don't know with certainty how many Milo sachets of a particular, maybe 1 kg or so, that customer will buy. But from historical record of how people are buying, the buying pattern of people over time, you can predict. So when you deal with those kind of problems where you don't know with certainty the operational parameters of how many units of all those items you store in ShopRite, because the demand is not known with certainty, so that you don't overstock on the stock. Because if you overstock, then in that case, don't forget all those items have expiry date, then that is what lead them to doing promo, then they release it at a very cheaper price. And that means they're losing. So that means the operation manager there is not really streetwise. So if you are really applying this concept that I'm talking about, you are able to properly plan how should you stock in such a way that you're not overstocking or understocking. Because if you run out of stock, then you're going to lose customer to other competitors, other markets, other retail shops. So when you deal with this kind of problem, When the operational parameters is not known with certainty and you want to solve a resource allocation or how many unit of product you're supposed to buy problem, then you must solve it using the probabilistic dynamic programming approach. Then you've got the fourth topic. So I'm just trying to give you an highlight of all these topics so that at least when we start the mathematical jargons, at least you understand why we are doing that. To say McKinsey, but he said this. So hence, okay, this mathematics is tailored towards doing this. Then it makes you appreciate the mathematics that we want to do. Unlike you chasing X and Y, but you don't even know why you are doing those things. But you knowing that, it makes you appreciate what you are doing. Then we've got topic number 4, which is deterministic inventory models. Deterministic inventory models. So with deterministic inventory models, how does this work? So with deterministic inventory model, the way this work is, you have got, with deterministic inventory model, you are looking at, let's look at inventory model, forget about whether deterministic or probabilistic now. So with deterministic, with inventory models, we want to see what are the existing mathematical models that could help us to effectively manage inventory so that we don't understock or overstock. And the word deterministic for topic 4 and topic 5, and there are various kind of inventory mathematical models depending on the nature of the inventory problem that you are dealing with. Hence, when we get to that module, we'll look at various kind of inventory models and what characteristics of that inventory problem can make us to use which kind of inventory mathematical model. So when we get to topic 4, we'll be looking at that. And how do we know whether that problem is also deterministic? Is synonymous to what I said with the dynamic programming. If the parameters of that inventory problem is known with certainty, then that means you must use any of those deterministic inventory models that we're going to talk about when we get to that topic. Hence, the reason why we have seen it in South Africa, most of the people that are calling themselves inventory control manager, if you ask them in terms of assessing their inventory management practices, you see that there's a mismatch between the inventory model that they are using and the nature of the inventory problem. Hence, sometimes they run out of stock for some inventory items. Sometimes they overstock for some items because you are not using the right inventory model. So I believe after the end of this class, you'll be able to learn how to use the correct inventory model to solve an inventory problem. So that if you are employed as an inventory control officer, or you are employed as a procurement officer in a particular organization, then you know which inventory model you're supposed to use to deal with managing inventory in terms of material required to render service or produce product in your organization. So that is what topic 4 and 5 looks at. But with topic 5, what makes it probabilistic is if maybe the item you want to manage, which is the inventory, if you don't know with certainty what is the amount of units which is demanded and which is required, that amount of inventory required, then in that case, that inventory problem is probabilistic in nature because you're going to use historical record of how that inventory has been used over time or required over time to now predict and use that to now know how many you're supposed to stock so that you don't understock or overstock. So we're going to look at series of examples, series of operational problem under that, and you're able to see how you can apply this if those kind of problem also relate to what you do at work. Or if you are maybe not employed yet, at least when you get job in that area, you know the right technique to use, operational management technique to use to deal with that particular problem. So I think the last one, which is network model, just to quickly highlight it, is the network model. And this is very good for people that are working because we try to cover as many stakeholders as possible. This is very good when you are dealing with connection problems. And this is good for people that are working at, maybe you are working at ESCOM or you are working with any power company. If you are dealing with, maybe you want to look at, you're trying to power a particular area in terms of connecting wires so that maybe that particular area can have electricity. And don't forget, you've got various houses in that area. Then how best you connect those wires in such a way that you minimize the number of wires required. And in that case, you're able to minimize the cost of doing that particular project. So when you are dealing with this kind of problem, which is network, we call it connection problem, then you must use the network decision-making techniques, which you are going to see, and that help you to come up with the best way of connecting those wires, or come up with the best way of connecting maybe those routers. If you are maybe working as a computer engineer, then you're dealing with connection problem, so that you're able to minimize the cost of connecting you're able to minimize the amount of wire required, which will reduce your cost. So if you don't really plan this well, then you are just going to overbuy wire, and it will increase your operational cost, then it will reduce your profit. So this technique exposes you to, if you look at everything we have been talking about here, it's all about coming up with strategies which is tailored towards what? Reducing operational cost, or what? Maximizing profit. If you look at everything we have been talking about, it's just that for all this topic, there are different kind of operational problems which will require you to use any of these mathematical decision-making techniques. So I think that's all in terms of giving you an overview of everything in terms of all the modules that we're going to do for this semester. So if you are still with me, just type Y on the chat window. If it still makes sense up to this stage, type Y on the chat window. If it still makes sense, please, let's respond. Thank you, Mashlango. Thank you, thank you. Thank you, thank you. Thank you, everyone. Thank you, Ofense. Thank you, Temba. Thank you, Madam Kale. Thank you, Sakiwe. Thank you. So I think so far, please let's respond and feel free to ask questions. So I think at this stage, we are going to start. And for me, I've already uploaded a lot of notes on D12. So the way we are going to work, we're going to start with an example now. So we are starting with transportation problem. So I want to take you to model now. So let me also go to model, then show you how to assess that note for the first topic. So try to go to model, please, colleagues. Everyone in the house, please go to your model, then try to go in. So I think we are fine. So we are starting with the first model. So I want to show you what is our learning objectives for this model, then where to assess the note for the first model. Then at least you know going forward you can do the same for the second and the subsequent topics for this particular model. So I will stop sharing, then I will share the model. Let me quickly log in. And please type Y if you can see. I'm here now on Ulink. I hope you can see what I've shared. Please respond by typing Y. Thank you. Good. So I'm going there now. Thank you very much. Thanks for the response. So I think we'll go in and try to go to UJ model, log in. So you can just click that. I'm not sure whether it's taking me to another page. I hope you are seeing the new page is taking me to. Please just confirm. If you are not seeing it, let me know, because it's open on another page for me. So then you go to your model. Don't forget your model will be appearing, which is OMT7X01. Then you can go in there. So I've opened mine. Just if you are not seeing what I'm saying, please just give a shout so that I know. So then from there, you can go and go to unit 1. Go to unit 1. You click on unit 1, you can see that we've got the learning outcome there. You can scroll down because there's a lot of blocks in terms of different information. You see there's learning unit outcomes. So that is the one you must first read so that you understand at the end of this module, what are we supposed to learn as students? So you click read more. Then from there, this is our learning outcomes. Please type Y if you can see the learning unit outcomes that I'm sharing before I move on. I know I'll be saying type Y a lot because I just want to make sure that we're on the same page. Thank you. Good. So the learning outcomes are here. What are we supposed to learn at the end of this transportation problem, which is the first module we're about to start it today? Just to warm up. Then from next week, we move with the right pace. And please, let me also quickly echo this. When you come to class, this is a mathematically inclined class. Don't eat pap, ne? Eat something light, because when we do mathematics, you are not supposed to be sleeping. You need to see. It's not a theory module. As I'm doing it, you must also be doing it and listening. If you have any question, ask. It's not difficult. I know most of you hate mathematics, but maybe through me, it can change your orientation about mathematics. Mathematics is very, very interesting. Mathematics actually is the English you speak. So if you understand English, which you claim you know, you must be able to know mathematics. So please don't eat pap. You can eat it after the class to rest and all those. So eat something light so that you can see what I want you to see. So let's move on. So here, like I was saying, since you said you can see it, what are we supposed to, what is our learning outcome? What are the learning outcomes for this model, for this particular topic? At the end of this topic or at the end of this unit, the first thing which we are expected to be able to do, we are expected to be able to formulate a transshipment or transportation problem or transportation model using the linear programming approach. We must be able to formulate a transshipment model or transportation problem using the linear programming approach. That's the first objective, and that is the one we are going to focus on today. So what that English is saying is, how do we convert a transportation problem that we are facing in a manufacturing organization or a service organization into a mathematical model? And when I talk about models, I know I'm talking about some things, terminologies which is confusing you. I will try to also explain to you so that you don't get confused. When we talk about the model we are talking about here, I'm not referring to the ladies in the class. The model we are talking about here, it's talking to when you talk about the model, a model is anything that represents a real life problem. So we are trying to, anything that represents a real life problem is a model, is a way of imitating a system. And why are we trying to formulate a model? Don't forget, we've got a transportation problem of, like I gave you an example of saying, you've got different suppliers who are maybe producing product or different warehouses that have got different products that needs to be shipped to different customers in various locations. And you want to answer the question of how many units should you ship from each of the suppliers to various customers staying in various locations, so that at the end of the day, you're able to minimize the cost. So if you look at that, that is a transportation problem or transshipment problem as a logistics officer. So how do I solve that problem? To solve that problem, the first thing I need to do as an operations manager or as an operations specialist is to find a way of representing that operational problem. And what you use to represent that operational problem is what we call a model. And the model, there are different types of models. That model can be a mathematical model. And that is what you are going to see here, where we find a way of formulating or representing that problem that I've said now, that transshipment problem that I've iterated now, find a way of representing it mathematically. So that if I have a mathematical model that represents that problem, then I can solve that particular mathematical model and get a solution to that transshipment problem, which I will now implement. I hope that makes sense to you. So I hope that makes some sense to you. So that is what a model is all about. So in this first, like I was saying, in this first outcome, we're able to see how can we represent that transportation problem, series of example of transportation problem that we're going to see. How do we translate that into a mathematical model? That is what we want to first achieve. If we're able to do that, then that means we are super. That's the first outcome that we want to achieve. Then the second objective is, and the third objective, second and the third objective, or the second and the third outcome is looking at how do you solve that mathematical model of yours, which is representing that transshipment problem, and get a solution which will minimize your cost of shipping. And to solve that, there are various steps which talk to the second outcome. The second outcome is to determine the initial basic feasible solution to that transportation model that you have formulated using the northwest corner rule. So that is the second objective. So we are going to see that during the course of the class session. It won't be today, but we are focusing on the first outcome today and see how far we can go. If we cannot finish, we'll continue in the next class. And the third objective is to now determine the minimum transshipment cost solution, because don't forget, at the end of the day, like I said, as an operations manager, any strategy you play in an organization, you want to make sure that is the minimum cost strategy. So there's a need for you to optimize any of your solutions to get to the best solution that will minimize your cost. Hence the reason why we're having that third objective, which is saying we want to determine the minimum transshipment cost solution to a transportation problem using another method which we call the stepping stone method. So at the end of this unit, you must be able to do those three things. So if it makes sense, type Y on the chat window so far. If you're still following, then we'll start. Please type Y on the chat. Good. Thank you. So now I think we are good. Good. Thank you. So I think that is your learning outcome. So when you are done with the learning outcome, you can see you need to go back. So how do you go back? Because some people get confused. They say after you click more, then you see this, you scroll down, you don't see where to go back. To go back to the initial interface where you can now see more information, you just need to go back to the same transportation model. Just go to the middle here where you have the remember we opened this learning outcome. Actually, you can go to the learning outcome because that's what we opened. Just click the same thing you opened on top so that it can return you back to the initial place where you are. Or if you click that, it's still taking me back to learning outcome, but go back to unit 1, which is transportation model, then it will take you back. Because if you click that same learning outcome, it will still be on the same page. But if you click the transportation model, the one before, because don't forget, the learning outcome is the child of that transportation model, which is the parent. So just go back to the parent of that child that you opened. So take note of that, then it can take you back. So now we are back to transportation model. We've seen the learning outcome. You can scroll down because there's still more information. And here you can, how do you get the note? This is the transportation note. If you scroll down, the note is here. So the note is here. You can download the note. So I can go here and click the note and download it. So just click on the note, then you can download it. Then you can click on download, then you have your note. Then you can save it as transportation problem notes anywhere you want to, transportation problems. So you can save it. Then in that case, you have your notes saved. And let me quickly say this to you. Don't forget, I'm opening as a lecturer, but in your own interface, don't forget you'll be seeing that interface as a student, so you'll be seeing all these things I'm seeing. If you're not seeing what I'm seeing, just indicate, then I would help you. So as soon as you are done, we are done with the transportation note, you can go back to transportation model again. So we have the notes now. And let me also quickly show you another thing. If you want to see the prescribed book, just go to learning guide and prescribed book. I've also uploaded the ebook for you. I forgot to also highlight that. So you can see the learning guide is here, 2024 learning guide. You can click read more. Then remember I was talking about you clicking here, you can click here. Then as soon as you click here, you get the learning guide and save it. and you can go through it. Then you can go back again to your learning guide so that you go back to the previous page where you are. Then you can scroll down, you see your prescribed textbook also there. I've also uploaded an ebook for you. You can read more. The prescribed book we are using is Operations Research Applications and Algorithms by Winnie Weston. And that book is here. You can see it here. Winston Operations Research. If you click it, you're able to download that ebook. So I intentionally gave you because some of you might not be able to, you prefer the ebook nowadays. So once I've loaded it, then you can download it and always have access. So I think with that being said, let's proceed. Let's proceed. So I will tell you when we about to use the book, but today let's start with one example and see how far we can go. But at least so far, at least I've shown you a few things on how to maneuver a model so that you know where to get information on model. So I would go to my transportation node now. So I'm going to stop sharing model. So now you know how to maneuver model. So I'll be sharing my transportation node. Just give me 1 minute, 30 seconds to 1 minute. So for transportation problem, actually, we've uploaded two, is there in the prescribed book, and I've also uploaded another note. So we try to look at maybe one example from the book and the notes that I also shared. We look at another example, but let's start with maybe the one from the prescribed book. So I'm going to project the prescribed book shortly. So I'll be sharing that now. I'll be with you. So here is an example. We'll still go to an example in that additional note that we downloaded. So we'll do one in the book. We also do one in that additional note. So that at least you have more examples that you can practice, more tutorial questions, because the more you practice, the more you master the concept. And in the test, you know how to solve the problem. You have confidence in solving the problem in the test. So where did I go now? I think I pressed something, just a moment. So we have this first example. So like I told you, when you deal with transportation problem, as the name imply, we are going to look at this problem together, which I'm also going to copy. So what we are going to do is we are going to put this information, I will open a Word document, we try to do it together. So before we do it, look at this example. It's a power core problem. They said power core as, I will read the scenario for you. Then we'll try to understand the scenario. And the question which you want to do is to first, please write, you need to write it down, and that is the way the question will be structured. You have a scenario like this, and the first question will talk to the first outcome that we said, which is to formulate a mathematical model or a linear programming model to minimize the cost of, that will minimize the cost of meeting each city peak power demand. So we talk to the first objective that we are trying to achieve. But before we go into that question, let's read the scenario. Then you see why we are saying this is a transportation problem. And when you read a scenario, let me also say this. Try to imagine the scenario, because in mathematics, don't just read as if you are reading newspaper. Read the scenario, immerse yourself in that scenario as if it's happening to you. Then don't forget, a problem which you understand is half solved. But if you don't even understand the problem at all, then you cannot even solve it. So try to understand the scenario. And don't forget at the back of your mind, like I said, when we are dealing with transportation problem, it's all about how do we ship product from various supply bases or suppliers to various customers to minimize the cost. So you have that fundamental understanding of the kind of problem we are looking at. So let's read that scenario and try to see how that play out in relation to what I've told you now. So we read the scenario quickly. The first scenario is saying Powerco has 3 electric power plants that supply the needs of 4 cities. So it's more like, let me also relate this scenario, it's more like you have got maybe different power plants that is supplying various cities in maybe Gauteng. And don't forget, each of the power plants, they've got a specific amount of specific capacity in terms of kilowatt hour of what electricity that they can generate, which will influence their supply capacity. And don't forget, maybe that particular power plant, it needs to supply some specific number of what? You've got different towns or different houses in Gauteng province. So if let's assume we have maybe 4 power plants in Gauteng and we've got different houses in Gauteng, then how best should this how many unit of how many kilowatt hour of electricity or how many load of electricity should be supplied to each house from which power plant to minimize the cost if you are the operations manager. So I'm trying to relate this scenario because this book, those people that wrote this book, they are from the United States, so we must relate it to what is happening within our own country. Hence the reason why I'm trying to give you an example that you can relate to. So when you read the scenario, you can already relate it to power supply problem within the South African context. So that at least it makes sense to you. So when you read a scenario, even if that thing is not within our context, relate it to what you know. Then in that case, it makes sense to you. So let's continue reading, at least since we know we are dealing with a power supply problem here. Powerco has 3 electric power plants that supply the needs of what? 4 cities. So in this case, this power plant, they are supplying the needs of maybe 4 cities, maybe within that particular area. And they said each power plant can supply the following number of what? Kilowatt hours of electricity. Plant 1, it can supply 35 million kilowatt hours of electricity. Don't forget, depending on each of the plant, don't forget, they have a capacity in terms of amount of electricity that they can generate. So the supply capacity of plant 1 is 35 million, meaning that when plant 1 starts supplying to these 4 cities, it cannot supply beyond what he has. It can only supply what he has. So hence, each of these plants, you look at it as supplier in relation to the theoretical background I gave you. So plant 1 is the supplier to all these 4 cities. Plant 2, the capacity is 50 million, meaning that plant 2 can generate 50 million of kilowatt hours of electricity easily. So that is the supply capacity for plant 2. Plant 3 can supply 40 million of what? It can generate and supply 40 million of kilowatt hours of electricity. So those are the capacity of the suppliers for 3 plants. So that means in this problem, we have 3 suppliers. We have 3 suppliers. So that is what we have noted. And that is also what this problem is saying. And we've got cities, we've got 4 cities that these 3 plants must supply. And what is the demand of this city? Because we also need to know for each of these cities, how many houses are there which will influence, and also depending on what they want to power in each of the houses in the city, what is the total demand for each city? So someone has done that investigation. And that leads to the second information. They say see table 1. So if you go to table 1, you can see in table 1, they told you plant 1, plant 2, and plant 3. You see their supply capacity, 35 million, because all these values are in million, which talks to the statement given up there. Plant 1 capacity, as you can see, the value is here, 35, which is a million. Plant 2 the supply capacity for plant 2 is 50 million. And the supply capacity for plant 3 is what? 40 million. It's 40 million. So let's move on quickly. The reason I'm taking it slowly for first example, I don't rush the first example because I want you to understand the science behind us. As soon as you understand it, for other example, they are synonymous. Then it's easy for us to move faster with the other examples. So then they told us again that the peak power demand in these cities, because I told you they have done the estimate of what is the power requirement in each of the city, which occur at the same time. They said it occurs at 2 p.m. as follows. So the peak demand as follows for city 1, maybe at a particular period of time, they require 45 million of 45 million kilowatt hours of what? Electricity. So that is the demand for city 1. You see city 2, it requires 20 million kilowatt hours of what? Electricity. And this is also what we can look at in terms of what is happening with what we are seeing in terms of power supply, why we are having load shedding, because the demand is more than the supply. Hence, they must load shed somewhere or find a means of maybe increasing their electricity generation supply, because most of the time, if you think about it, as soon as maybe the turbines and the boilers responsible for generating electricity, as soon as they are down, then in that case, we are losing, because that means the machines are down, then they are losing production. Hence, what they can generate will be low. And in this case, the demand is more than supply. Hence, they have to load shed at some point. So, and that goes back to, if we are to investigate, that talks to maintenance issue and some other issues, which I'm not going to look at. But if you are to look at what ESCOM is doing at the moment, it talks to what you are seeing here, where ESCOM is saying, look, irrespective of maybe the operational inefficiency in our organization, this is what we have. We can only produce this, and we are trying to address the inefficiency also. So after addressing the inefficiency, applying the operations management techniques, our supply capacity for each of these power plants is this. And each of these power plants must supply maybe those various cities. So the question is, what is the total supply? What is the total demand? And if we know the supply, if we know the demand, then how best should we supply? Which power plant must supply which cities within outing? So that at the end of the day, even as they do their supply, they are doing it in a very cost-effective manner. So when you deal with that kind of problem, you are dealing with transportation problem. So I hope that makes some sense to you. So let's move on. I'm just trying to say this so that all this, especially for those people that didn't do mathematics or didn't do operations from the start, at least you tend to relate it with in line with those examples I'm giving, then it can make sense to you. So let's move on. So we said city 1 is 45 million, that's their demand. Then city 2 is 20 million, city 3 is 30 million, that is demand for city 3. Then city 4 is 30 million. So what we need to do, so I'm going to stop sharing, and after you have read the scenario, maybe let me finish reading everything, then would. The first thing which you need to look for in a transportation problem, what is the supply capacity of each of the supplier? We have seen that. Take note of that as the parameters given in the question. Take note of it. So I'm going to be switching between a Word document and the notes, because when you read the scenario, all the parameters given, you write it down. So I'm going to open a Word document, because we are going to do it together. So let me stop sharing this, then open my Word document. So please confirm if you can see what I'm sharing, the Word document. Let me zoom it a bit. Okay, thank you. Cargo transportation problem. This is example 1 that we are looking at today. So the first thing which you need to note, just say parameters given, meaning that you want to highlight what are the parameters given in that transportation problem. At least we have seen, don't forget, I told you when you look at the transportation problem, you are looking for the suppliers in the scenario and the customers who are requiring something from the supplier. So we've seen that we've got plant 1. So you write it down, plant 1, supply capacity. Plant 1, supply capacity. Please just make sure you download that ebook and look for it. Look at it there. If you look at that, plant 1 supply capacity is 35 million. So let me write it down. Then plant 2 supply capacity, I will just copy this and just edit to make it fast. Plant 2 supply capacity, according to what we have read, is 50 million. Then plant 3, because we have 3 plants. So all the suppliers, you need to note them down and note their capacity down. And please don't forget the first question you get, first question that will be asked from that scenario. Let me also type it here. For any test that I'm going to give you on transportation, the question will be structured like this. Formulate a linear programming model. A linear programming model to represent, that will be the first question, to represent this transshipment problem. And that talks to our first outcome 1 that we want to achieve, which is that power co-transportation problem in this scenario. So that will be the first question. And that is what we want to do. So let me make it bold. So take note that it will be the question. So you note the suppliers, then you note all the customers in the scenario. So don't forget the customers are city 1. They told you the demand for city 1, if you go to that scenario, the demand for city 1 is 45 million. So you write it down, 45 million. Maybe I should just, because I want to save space, city 1, 45 million. That's kilowatt hour of electricity that they demand because of the appliances and things that they need to do in all the houses in that city. Then city 2, plant 3 capacity, let me quickly see, plant 3 capacity is 40 million. So let me change it. Then city 2 demand, please make sure you confirm no mistake. Just note all the parameters and write them out. City 2 is 20 million. 20 million. So I'm going to write this out. Then city 3. City 3 is, city 3, the demand is 30 million. City 3, demand is 30 million. Then let me just put city 4 beside here just to make life easy, so that we can see everything at once at a go. Then city 4, the demand is 30 million. City 4, let me check. City 4 is also 30 million, yes. City 3 and City 4 has the same demand requirement, 30 million. So that is what we are given up to that stage that we have read in the scenario. So as soon as you read the scenario, when you identify the suppliers and the customers, note it down like this. So at this stage, we'll pause here. Let's continue reading. So I will stop sharing the Word document. We'll come back to it. And let's read the other part of the scenario. I will stop sharing. Then let's go back to the textbook because we'll be swapping between the textbook and the notes that we use to solve so that it can make sense to you. So when you read the scenario, you've noted all those parameters, you write them now. Then let's continue from where we stopped. You remember we stopped at the City 4 demand requirement? Then the next statement is saying, that's what I'm saying, when you read the scenario, don't read it as if you are reading newspaper. Make sure it makes sense so that you're able to correctly identify the parameters. Like I'm doing. You see, I'm not rushing. I try to make sense, but it doesn't mean you must be slow forever because you would have understand the concept. That's why you must practice so that you understand and you know when you see a scenario, you know what I'm looking for and you know how to go about it. So the next statement is saying the cost of sending 1 million kilowatts of electricity from plant to city depend on the distance the electricity must travel. So how far must the electricity travel from the supplier base, which is the supplier location, to where is required? Because don't forget, they have to maybe ship it via various means or mechanism, which means it must be powered maybe by petrol or something. And that means if they are going to ship the electricity also, then they have to think about how best should they ship the electricity so that they don't incur more cost. They want to reduce their cost. And they told you that that cost actually, it's also indicated in the table. If you look at it, if you go to that table 1, they have already captured that information for you to say the cost of shipping. If you look at it, they said the cost of sending 1 million kilowatts of electricity from plant to city depend on the distance the distance must travel, which is shown in that table 1. So in table 1, if you see it from plant 1 to city 1, if you want to ship 1 million kilowatts from plant 1 to city 1, it's $8. And you can see for the demand for city 1 is 45, which is a million kilowatts. All those things we said in terms of the demand is stated underneath in the row, which we have noted in our Word document. So the cost of shipping just 1 million kilowatt of electricity from plant 1 to city 1, they have done their costing. Depending on the transportation mechanism that they are using, they see that just to ship 1 million kilowatt is $8 from plant 1 to city 1. From plant 1, so they did all the analysis of shipping, the cost implication of shipping from one plant to each of the city. What is the cost of shipping just 1 million kilowatt? So they got that information because the question is how many units should we ship from plant 1 to city 1? Is it really cost effective to even ship from plant 1 to city 1, or we should go from plant 1 to city 2? Who must supply which city from which plant? Those are the kind of questions we want to answer. That is why it's a transshipment problem, so that at the end of the day, we're able to minimize our cost. So if you look at this, that information in the table is already telling you from plant 1 to city 1, the cost of shipping 1 million kilowatt of electricity is $8. From plant 1 to city 2, cost of shipping 1 million kilowatt is $6, and so on and so forth. Plant 2 to city 1, the cost of shipping is $9. But let me see whether you are following, because I always like to ask questions so that we can see whether we are following. What is the cost of shipping from, based on the table you are seeing? Yeah, the cost of shipping 1 million kilowatt from plant 3 to city 4. From plant 3 to city 4, please type the answer on the chat window. Based on what you are seeing on the table, I just want to see whether you can interpret the table the way I'm interpreting it. From plant 3 to city 4, what is the cost of shipping? $5. Let's see. Plant 3 to city 4, correct, $5. So I'm asking this so that at least I see that you're also following. Thank you very much. So we know all this cost now. So since we know the cost, all the information is given. The first question you are now giving is formulate a linear programming problem, a linear programming model to represent this transshipment problem. So how do we go about it using these parameters given? The first step, please listen and listen carefully. The first step is not difficult. Now I'm going back now to the Word document to show you how we do that. It's not difficult at all. And after doing this first example, I will give you some maybe 2-3 questions for you to try at home. Then let's see whether you get it right. And I will advise you, please work in groups. Group leader, send me your solution. I will go through it for you. Then I will advise whether you are sharp with your solution. So let's quickly go back to the Word document and continue now to answer that first question being asked, which talks to the first outcome. So I'm going to the Word. So the first step, when you want to formulate, step 1, to make it easy. Actually, when you do this, you don't need to write it like this. It's because I'm explaining. You just go and do that step. But because I'm teaching for you not to forget, step 1, you need to generate a transportation network diagram, or create. Maybe I should use the word create. I don't really like English that much, but create a transportation network diagram, but I like mathematics. That's what I like myself. Create a transportation network diagram for this transportation problem. That's the first step. For any problem, this is the step you start with, because if you create a transportation network diagram, it makes your formulation very easy. You can see from the network how to formulate easily. And when we mean by transportation network diagram, it means that in a transportation network diagram, you have all the suppliers on the left-hand side in that column. Depending on how many suppliers you have, you are going to create many circles to represent each supplier. And on the right-hand side, you are going to have, anywhere on the right-hand side, you are going to have also many circles to represent the demand network. Supply network is on the left-hand side, you represent each of the supplier by a circle, and you are going to have supplier 1, supplier 2, supplier 3. Depending on how many suppliers, if you have 5 suppliers, you have 5 circles. If you have 7 suppliers, you have 7 circles on the left-hand side. Then you go to the right-hand side, the demand, depending on how many people that require information, the customers. In this case, we have 4 cities. So that means we are going to have 4 circles for the demand network on the right-hand side. So let's do that together. That's the first step, to create a transportation network diagram. So let me quickly create that for you. So I'm going to be using some nice shapes here. Let me see quickly. So, no, I just want to make it black. I'm just designing here. So I will just call this one S plant 1. Let me call it P1. Don't forget, we mathematician, we don't write. You don't need to write the O plant and all those. I know P1 is talking to plant 1. So you can define a legend to say P1 is plant 1, just to make it very neat. So we just write in shorthand when we do mathematics. And you define your parameters to say P1 is plant 1. And P2 is plant 2, and so on and so forth. So I'm going to have, don't forget, I have 3 plants. So I'm going to create 3 of these circles. If I have 4 plants, I'll create 4 on the left-hand side. So I'm going to copy and paste quickly. So if we can do this first example, then I think we'll call it a day. Then we'll move on next class. Because I want to finish this example, then I give you tutorial question to practice what I've done, to master that outcome 1, which is being able to formulate a mathematical model to represent a transportation problem. So I've got these 3. So I'm going to edit this. This is plan 2, plan 3. And this is the supply on the left-hand side. On the right-hand side, like I said, anywhere on the right-hand side, just place it anywhere. We generate 4 customers, which are the 4 cities. So that means we're going to have 4 circles. So I'm just copying and pasting. So I can place it anywhere so that it's not too far. So I'm going to say this is city 1, C1. So you can define the legend or you can leave it like this because we are mathematicians, I understand. But use a parameter that is easy to understand. But if you are using new parameter, then define your parameters below so that I know what you are using to represent each of the supplier or each of the city. And I'm not confused when I'm marking your question, your answer to this question. So I'm going to maybe shift this one on top a bit because I have 4. So I want to make it go up a bit. So let me maybe shift this down because I have 4 there. So I want to at least make sure that I can see. It doesn't matter where you position it, but just to make it look nice. So I'm going to push 4. Yeah, I think I'm happy now. I'm just trying to make it align, but it doesn't matter. What is important is just have the network. So I've got this. So I'm going to just edit this to be C2, C3, because this is CT3 and CT4, because that's the demand network. If it makes sense up to this stage, type Y on the chat window before I continue. Does it make sense? Good. Thank you, Sakiwe. Let's move on quickly. Good. So then the next thing, if you look at our table, if you remember that table 1, they said, don't forget, the question we are trying to answer here is, any of this, look at this problem. Any of these plants can supply any of this city. But the question is, which plant should supply which city? But any of them is a potential candidate of supply each of the city. So that means we have to look at all the possibility and look at the, out of all the possibility, which of them are the cost-effective shipping routes. So that means when we form our network, we draw a network that represents all the possibilities, meaning that plant 1 can either supply city 1 or city 2 or city 3 or city 4. So I need to draw an arrow that moves from P1 to C1, P1 to C2, P1 to C3, and P1 to C4, because that plant 1 can either supply any of these 4, but which one or which of the cities should P1 supply? That is another question which we need to answer, which leads us to the second outcome of this model. And P2 can also supply either C1 or C2 or C3 or C4 or CT4. So that means I will draw a network from P2 to C1, P2 to C2, P2 to C3, P2 to C4. Plant 3 can also supply either CT1 or CT2 or CT3 or CT4. I'll draw a line, a network, which is an arrow from P3 to C1, P3 to C2, P3 to C3, P3 to C4. If I do that, let's quickly do that. Then from there, I'll have my final network. If I do that, let me show you quickly. I just draw a network. So you don't need to dress the arrow. So it's up to you, but just make sure it makes sense, because we said P1 can either supply thus C1 or C2. No, let me leave the arrow like that. Then let me go again quickly. Then I do that again. That's why I told you the mathematics you are doing is the English that you are interpreting, the mathematics you are afraid of. So if you know English very well, you're supposed to know mathematics. Then P2 can either also supply CT1, you continue like that. Or CT2, or city 3, or city 4. Then the next one quickly, insert. P3 can supply city 1 or city 2 or city 3 or city 4. And that is my final network. That's the first step. So does that make sense? If that makes sense to you, type Y on the chat window. Before we go to the next step, we're almost getting there. Type Y. Good. Thank you. Good. It's just, I hope my electricity will be back because my laptop is almost dead, but let's push. Let's just hope they will bring electricity. But we are almost there. So let's quickly, then now the next thing which you need to do on the network, you need to go and populate. You need to go and populate the cost of shipping. You need to populate the cost of shipping. You remember in the table, they tell us how much is the cost of shipping 1 million kilowatt of electricity from each plant to each city. So we need to put that in the network. So I'm going to quickly put that quickly so that we can see on the network, okay, from plant 1 to city 1, if I want to ship 1 million kilowatt of electricity from plant 1 to city 1, according to the table, based on the costing that they have done, what is the cost? So I must see it also on the network. From plant 1 to city 2, I must see the cost of shipping 1 million kilowatt of electricity. So I'm going to put that there quickly for you. Let me do this. Let me add text. So for city 1, from plant 1 to city 1, they said it's $8. So I'm going to put 8 here. So I will try to make it, let me remove the outline, no outline, let's see. So I'm just going to take this here, no, I need to make the fill also no fill, so that when I move it, I think it would, yeah, I'm happy. So I can put it here, meaning that this is $8. So let me just put dollar so that at least you can relate it in relation to the table. So you put it anywhere around the arrow. So it makes you see that from plant 1 to city 1 is $8. So let's go again. I can quickly replicate, copy and paste. Plant 1 to city 2, let me just place it closer to where I can see it so that it doesn't cross on the line. Plant 1 to city 2 is $6. So I'm going to add this to become 6. Then plant 1 to city 3, just place it anywhere so that at least you see it on the arrow to say that arrow is going from plant 1 to city 3. And you can see the cost. The cost is $10. Then plant 1 to city 4. Plant 1 to city 4, I will just place it here so that I can place it in a place where I can see it. Plant 1 to city 4. Plant 1 to city 4 is $9 according to table 1. $9. So with that, I'm done with plant 1 in terms of populating the cost based on the table. I will repeat the same thing for plant 2 to city 1, plant 2 to city 2 until I finish. Plant 2 to city 1 according to the table. Plan 2 to City 1 is $9. Plan 2 to City 2. Plan 2 to City 2. I'll put it somewhere here. Plan 2 to City 2 is $12. Then Plan 2 to City 3, according to the table, you go and check it. Plan 2 to City 3 is $13. Please don't make mistake. Make sure you are picking the right value, because as soon as you make mistake, then it throws you out. That's the problem with this computation. Plan 2 to City 3 is $13. So I'm placing it in a place where I can see it easily. In terms of the arrow linking from P2 to C3, I can see the cost. Then Plan 2 to City 4, I can place it somewhere here so that at least I can see it easily. Plan 2 to City 4 is $7. So I change this to 7. Then I go again, Plan 3 to City 1 quickly. So don't forget where you position the cost is up to you, but just make sure you are placing the place that when you want to look at the arrow and you see the cost from that plan to that city, is easy for you to see. Plan 3 to City 1 is $14. Plan 3 to City 2. Plan 3 to City 2, you can place it somewhere here. Plan 3 to City 2 is $9. Plan 3 to City 3. Plan 3 to City 3 is somewhere here. I'll place it somewhere here, then I can see it. Plan 3 to City 3 is $16. So I'll just make this 16. Then Plan 3 to City 4, which is the last one. Plan 3 to City 4. Plan 3 to City 4 is $5. So I place it there. So that's the first thing. Then again, what I need to do, we're almost there, we are getting there, is to put the capacity, because now we are going to use this network to formulate. Let me bring, I want to bring the field back. Let me use blue color. So now I want to deal with the capacity now. So what you need to do, we need to talk about the capacity. You remember, if you scroll up, let me still put this back. You need to put the capacity. You remember we wrote it down, giving parameters. Plant 1 supply capacity is 35 million. So I'll just put 35 here. I don't need to put million. We know it's in millions. So we just can just say, no, let's just put it in, let me just say 35. It's fine, let's put it so that at least we know it's 3 zeros like that. So I'll place this one here for plant 1. Then for plant 2, because we want to know the capacity. The reason why you are putting it in the network, you understand now, because you know that when you do your formulation, you need to obey these rules of the capacity. For plan 2 is 50 million. So I'm going to, beside it, make it 50 million here. And for plan 3, you can put it beside it because I don't have space. So just put it neatly and very close to where you have your P2. Then plan 3 is 40 million. I can put it somewhere here. Don't let it touch the 50 million. Let me just put it by the side, it's fine. Then City 1 is 45 million. terms of the demand, 45 million. Then city 2 is 20 million. City 2 is 20 million. You can see that this module, that's why I say you need to be in class, because it also requires time when you do it for the first time. It's easy if I'm doing it, but because I'm teaching you, I need to take it slowly so that you understand. It's better than we do it slowly than rush and you don't understand. And what we did last year, if there's a need for extra class, we just create extra class session than to rush. But if you master it and you do well in the test, that is what is important. And you are smiling all the way after the test, then it's good. Than to rush, then we don't know anything, then we fail the test, then it's a problem. It won't really help us. So please take note, if there's a need for extra class, we try to create it and make sure that we understand everything that we can do well in the test and we can all smile at the end of the semester. So CT3 is 30 million. So this will be 30 million. And CT4 is 30 million. Let's hope I'm not copying the wrong thing. 35 million, 50 million. This one is 40 million. Sorry, I forgot to. Then CT1, 45 million, CT2, 20 million, CT3, 30 million. Then CT4, 30 million also. So that is how you populate your network. You populate with all the parameters. And what is this thing saying? What is it saying before we go into the formulation? If you look at what we have done in the network, this is telling us that, look, when you supply from plant 1 to any of this, anything that this plant 1 will supply these 4 cities, it should not exceed its capacity. So that is the mathematical formulation we are going to formulate. To say, depending on how many unit plant 1 will supply to C1, which we don't know, depending on how many units plant 1 will supply from plant 1 to C2, which we don't know yet, depending on how many unit plant 1 will supply to CT3, which we don't know yet, anything this plant 1 will supply to all these 4 should not exceed what plant 1 has, because you can only give what you have. And that is what we call the supply capacity constraint. Because you cannot give what you don't have. You can only give out what you have. The same thing with the demand. We're also going to have demand capacity constraints. So when you do your formulation of the linear programming model now, let me quickly, even if we don't finish it, but we'll try to push it to a particular level. So now we are talking about formulation. Now using that, that's the next step, formulation of the linear programming model. The first thing is we have to formulate what we call the objective function. You formulate the objective function. When we talk about objective function, what are we talking about? What are we trying to achieve from this transshipment problem? If you go back to the problem, if you read the statement there, if you go back there to the problem, what they were trying to do is they said formulate an LP to minimize the cost. So you can see the objective is to minimize the cost. Any transshipment problem, definitely, we want to minimize the cost of shipping. That's the objective. That's why it's an objective function. So you can already write it down to say our objective function is looking at minimizing. But in this case, you don't need to write it when you master it. Just write your mathematical formulation. But because I'm still teaching you, I still need to write it out so that you understand it before I write the mathematical equation. Minimize the cost of shipping electricity from plant I will call it plant I, to CTJ. I will tell you what that means now, to CTJ. That's why mathematics, some of you get confused. They say, why are we talking about J now? Where I, don't forget how many plants do we have there? There are 3 plants, right? Because I don't want to write many stories of saying from plant 1, plant 2, and plant 3. So I'm just saying from plant I, where I equal to 1, 2, and what? 3, because we have 3 plants. If we have 4 plants, then it will be 1, 2, 3, 4. And J equal to, we have 4 cities. 1, 2, 3, and 4. Does that make sense? Please type Y if you're still happy with what I've done so far. Does it make sense up to this far? Or if you have question, please let's respond. Moletani, Olen, I hope you're still with me. Good. Thank you. Perfect. Good. So I think it makes sense. So that is what we are trying to do. And how do we formulate the mathematical expression of this? That is the question. To be able to know the mathematical expression that will help us minimize the cost. Mathematically, if you look at your what do you call it now? If you look at your network, what you want to know is the total cost, which you want to minimize is a function of what is the cost of shipping only 1 million kilowatt of unit from any of these plants to each any of the city, which we know the cost of shipping just 1 million. Then how many units are we shipping from each of these plants to each city? We don't know. So since we don't know all those unknown variables in terms of how many units should we ship, we call them decision variables that would help us to achieve the objective function. So decision variables are the unknown variables, which is how many units should we ship from each plant to each city. So that means we are going to have a variable which is we are going to have many variables which are unknown in terms of how many units should we ship from each plant, which are 3 plants, to all these 4 cities. So that variable which is unknown, because we don't know them, we represent it by a parameter because it's an unknown. That's why we're always busy chasing X and Y. So in this case, we represent it as, quickly, if we can write the objective function today, maybe we can pause. It's just that unless the electricity comes back, because my system is almost dead. But let's see how far, unless the electricity comes back, but let me see how far I can push. So we define a decision variable. That's the next thing, which talks to the unknown. Define the decision variables. We talk to the unknown that tells us how much we must ship. And in this case, our decision variable, the way we do it here, we can use any letter of your choice. But don't forget, we need to know how many are you shipping from each supplier, which is represented by I, plant I to city J. So that means if I say let X represent how many units, so don't forget, it means that I must be talking about Xij. So Xij will be my decision variable because it can be, if you look at it in terms of network, how many units you are shipping from plant 1 to city 1 will be talking to X11. From plant 1, which is I, to city 1, which is J, meaning that how many units you are shipping is talking to X11 here. How many units you are shipping from plant 1 to city 2 is talking to X12. How many units you are shipping from plant 1 to city 3 is X13. So I will place all those decision variables beside the cost now. But I want to define it first. So I will now say let Xij be the number of unit, what do you call it? Unit of let it be the number of millions, because it will be millions. Number of, because don't forget everything is in millions. Number of million kilowatt hour of electricity. Because don't forget, now the light is back. I think I'm fine. I'm fine now. I hope they would. They will soon take the power. So the electricity is back. So let me just see. Hopefully. So I think electricity is back is fine. So we can continue. XIJB, the number of million kilowatt of electricity to be shipped from plant I to CTJ. And I any unit to machine from plant 1 to CT1. From plant 1 to CT1 is X11. So we have many decision variables because we can shift from different plant to different city. So I'm going to put all those variables on the network so that you can see them now. So I'm just going to copy this. That's why instead of writing let X11, X12, you see I've defined it in a very strategic way because mathematician, we don't write many stories where your I in this case is 1, 2, 3, and J is 1, 2, 3, 4. So you easy for you to see all those decision variables. They need to make sense to you. So I'm going to put all the decision variables closer to the network, which is, let me just insert equation X11. So I'm just putting that. So that shows you that how many units we need to ship from plant 1 to CT1 is X11 based on the way we have defined our variable is unknown, which we need to go and find. We don't know it. So for us to find it, we have to write a mathematical expression to go and solve this X11 and all those other decision variables, which are the unknown variables that help us achieve the objective function. So I'm going to copy this, paste, and try to do the same thing. This will be X12. So that is how many units must you ship from CT1, from plant 1 to CT2. Then let's move right along because I want those to finish. Let me just put it here because I don't want you to mess up. Just put it in a place where you can see the information. X1, this is, I'm not putting it in the right place. X13 is somewhere here. Because I want to put it closer to the arrow of 1 to 3. X13 is here. So don't put it wrongly so that you don't misinterpret when you do the formulation. Then X14 is here, which is 1 to 4 there in that arrow. So I'm going to put it somewhere there. X14, I can put it here. I just want to put it in a place where I can see. X14 is there. Then X21 is somewhere here. 2 to 1. So you can see you have many decision variables for this problem. Many decision variables. X21, let me see where I can put it. I can decide to put it here also. It's up to me. So far I can see that it's talking to that arrow. X21 is there. Then X22. So you can see you have many decision variables. That's why this is a complex transportation problem, because you have to find all those variables. X22. X22 is here. Then X23 from plan 2 to city 3. X23. X23, let me just put it somewhere here, closer, and I can see it there. X23. So X23, that is there. Or I can maybe, so that I don't mix it with X14, maybe I should place it closer to the side. Then I can see it's talking to 2, 3, because 1, 4 is the one going down there. Because you're trying to place it properly so that you don't mix it with other things and you don't get confused with the network. Then X24, if you like, you can place it closer to the number so that you don't get confused. And make sure you always confirm on the table also, so that at least you know, because when you misinterpret the parameters, then everything will be wrong. Then X3, from 3 to 1, that is X31. So I can go and put X31 closer to this. Then it makes me see it. Then X32. X32 is somewhere here. And put it there, 32. Then X33. X33. Then X34, which is the last one in terms of how many units must we ship from plan 3 to city 4, which we don't know how many. We need to go and find out when we solve the mathematical model which we want to formulate now, which will be in the next subsequent class. We try to solve them. So in this case, we have written all the parameters, all the decision variables. So now in this case, it's easy for you to write the mathematical expression of your objective function, because what we want to minimize is what is the total cost of shipping from plant 1 to city 1, plant 2 to city 2, plant 1 to city 1, plant 1 to city 2, plant 1 to city 3, plant 1 to city 4, then plant 2 to city 1, like that, up till you get to plant 3 to city 4. So we want to go and minimize that total cost. So to have that mathematical expression of the total cost, you need to ask yourself, don't forget, just to ship 1 million kilowatt is $8. Depending on how many millions of kilowatt you ship, that will give you the total cost. That means the cost of shipping from P1 to C1 is 8 times X11. Do you agree with me? Do you agree with me? The cost of shipping, the total cost of shipping for P1 to C1 is 8 times X11. If you agree, type Y on the chat window. Do you agree with me there? Do you agree with me? Please respond. Mashlangu, Moletani, just respond on the chat if it makes sense. Thank you. Please don't be tired of responding. This is mathematics. You need to be alive, please. So it's 8 times X11 from for P1 to C1. Then from P1 to C2, the total cost is 6 times X12. Then for P1 to C3, the total cost of shipping is $10 times what? X13. So you are going to sum all those costs together, 8 times x11. So that objective function, which is the mathematical expression of the cost, is 8 times x11 plus 6 times x12 plus 10 times x13 plus 9 times x14. That is for the P1. You go again, you continue adding. Plus 9 times what? X21 plus 12 times x22 plus 13 times x23 plus 7 times x24, which is 7x24. So we are done with P2. You continue adding again until you get to the last one, plus 14 times x31 plus 9 times x32 plus 16 times x33 plus 5 times x34. So that is the mathematical expression of the cost, which you're supposed to now write down here to say, my objective function is minimize, which I will show you. Maybe I don't need to write it. Maybe I'll write the other ones. I will stop sharing, then I will show you how they wrote that. Based on what I've analyzed to you on the network, that's how they get the objective function. We want to minimize the total cost, which you can represent as Z, to be 8 times x11 plus 6 times x12, which is 6x12, plus 10 times x13, which is 10x13, and so on and so forth, the way I've interpreted it. So if you do what I've said now, you have this final expression of for your mathematical expression of the objective function, which I will show you in the textbook quickly. Because of time, I won't write it, but I've shown you how you do that, how you interpret it from the network. So let me show you the final expression in the textbook. So if you have done what I'm saying, you see the way I've interpreted it. You see that they were able to write the objective function as, you look at what I've shown you, this is that mathematical expression. The way I've said it, 8 times x11 plus 6 times x12, remember the way I've analyzed it, plus 10 times x13 plus 9 times x14, until we get to the last one of 5 times x34. The way we have analyzed it on the network. So just make sure all the parameters on the networks are correct. Then if you do that correctly, you have that. And what you have on the left-hand side, want to minimize the cost. So that cost, we are representing it as capital Z. So that's why you see them writing minimize Z, which is the cost, to be that expression based on what you have seen in the network. So I hope that makes some sense to you. Does it make sense? So you see why the network is very important, because if you have put everything in the network, it's able for you to pick everything and start writing it from there, then start adding it until you get to the last one, then you write the final expression like this. Does the objective function make sense? Please respond. Good. Please, let's respond. Please, 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 please. Thank you. Good. Good. Thank you. So I know some people are leaving mathematics. It takes time. Please don't leave. Be there. It's very important. So we're almost there. It's just the first example. That's why it's taking time. Let me quickly help you with the other ones quickly, then we call it a day. I think before 8:30 would be done, by 8:30 somewhere there. Because the part which is difficult is the part I'm explaining, and I don't want to rush it. You need to understand it. And I want to make sure I give you exercise. Hence, the reason I want us to finish it, so that you can master what we have done today. So let me quickly, so that don't forget that mathematical expression of the objective function, you can write it now. So that mathematical expression of the function, it will be subjected to some set of constraints. So don't forget, you have your objective function, which is minimize cost, which is that expression that I showed you, the expression in the textbook, and I've shown you how you obtain that expression in the textbook. That's the mathematical expression in the textbook. So when you write that mathematical expression in the textbook, don't forget I told you that cost, you represent it as Z, because we want to go and solve that cost, which is the minimum Z. So you now say subject to. So how many constraints do we have in this problem? It must be subject to some set of constraints. So the constraints we have in this problem are the supply capacity constraints, meaning that anything each of these supplier will supply to all the cities, the total amount they will supply should not exceed their capacity. So that means in this problem, we have 3 suppliers. So that means we are going to have 3 supply constraints. See, 3 supply capacity constraints. And here we've got the demand in terms of the customer that require specific number of millions of tons of electricity. Anything all these plants will supply them should not exceed what they require. That's the demand capacity constraint. So that means since we have 3 suppliers, we are going to have 3 constraints to write for each of the supplier, which is each of the plant. And we have 4 cities for the demand, we are going to have 4 constraints. So meaning that we are going to have 7 constraints altogether to add to our LP model, meaning that you have your objective function subject to the set of constraints that you need to obey, because you can only supply what you have and you can only give the customer what they require. Hence, that's what we are trying to say. When you minimize this cost, you must minimize it in such a way that you're only supplying what is required. And you cannot supply what you don't have. Hence, we are writing those constraints to say, when we solve that problem, we must solve it in such a way that we obey those constraints. So let's start with the supplier capacity constraint. How do we write that? Meaning that this plant 1, let's start with the plant 1 supply capacity constraint. Anything this supplier plant 1 will supply to either city 1 or city 2 or city 3 or city 4 should not exceed its capacity, which is 35 million. And if you look at it, what he wants to supply from plant 1 to city 1, we have represented it as X11, which you don't know how many. But we want to write the mathematical expression based on those unknown, meaning that X11 plus X12, based on the English that I said, that anything plant 1 will supply to any of these cities, which is city 1 to city 4, should not exceed its capacity. So it means that translating that English to mathematics, it means that X11 plus X12, because that is what you are supplying from plant 1 to city 2, plus X13 plus X14 should not exceed 35 million. Should not exceed 35 billion. And don't forget, we know that all these values are already in, all these X, they're already in millions. So that's why I told you might just remove these millions. It should be less than 35. Because don't forget, we said this cost is the cost of shipping 1 million. So X11 here is talking about maybe if you are going to ship 2, which is 2 billion or 3 billion, depending on what the value is. So even when you write your expression, you don't need to write million, because all the variables according to the formulation, they are in millions. Even when we talk about the cost of shipping from 1 unit from plant 1 to city 1 is already 1 million kilowatts. And the cost of shipping 1 million kilowatts from plant 1 to city 1 is $8. So that means when I write now, I will just be saying X11 plus X12 plus X13 plus X14 should be less than or equal to. So let me just show you. Don't forget, when we say it must not exceed 35 million, mathematically it means it must be less than or equal to, from your law of inequality. So that means you have this. We're almost there. Is that thing? Did I wanted to copy that thing? Copy. Oh, let me copy it from here. Okay, is here. So I've got X11 plus Don't know why this thing is messing up. Let me see. X11 plus, why is this thing giving? Let me do this. Let me see this one. Maybe this one will work because that one is X11. Let me use this one. Plus X12. We are getting to the last phase. X12 plus X13. I've shown you on the network how I'm writing that. Plus X13 plus X14. And don't forget, I got this thing from the network by checking the network to see supplying from plant 1 to any of those cities. Anything I'm going to supply should be less than or equal to that 35 million. And don't forget, everything is in million. So you remove the million because they already told you in the table that all those values are in million. So I'm going to say should be less than or equal to, because when we say should not exceed, we can only supply what we have. So we cannot supply above what we have. Should not exceed 35 million means it means that it's less than or equal to. Less than or equal to 35. So that is the supply one capacity constraint, meaning that X11 from plant 1 to city 1 plus from plant 1 to city 2 plus from plant 1 to city 3 plus from plant 1 to city 4. Anything we supply from there should not exceed 35 million, which is 35 million, because everything is a million. Then you go again, you go and do supply two capacity constraint, follow the same principle, copy. I'm going to edit that. So if you check it on the network, hence the reason why you have in the network, so that you can see what are you picking there. From P2 to C1, that is X21 plus X22 plus X23 plus X24. Hence, you see why the network is very important for you to see how to write the expression correctly. X21 plus X22 plus X23 plus X24 should not exceed the I'm back. I think it's the network that kicked me out. Let me see. The network kicked me out. Sorry for that. I'm back now. We're almost there. Sorry. Because don't forget I was load shedding, so I was using my phone. I forgot that I'm supposed to switch back to the UJ network. So let me quickly share this. We're almost there. And from there, I'll be releasing you. So like I was saying before the network kicked me out, we are going to X31 plus X32 plus X33 plus X34 should not exceed the 40 million. So that's what we have done. X31 plus X32 plus X34 should not exceed X31 plus X32 plus X33. As you can see in the network, is 31, 32, 33, 34. 31, which is that arrow, 32, which is the second arrow, 33, 34, should not exceed 40 million. Then in that case, you are going to have less than or equal to 40. Then from there, those are the three suppliers. So those are the three supply capacity constraints you have. If you have 4 suppliers, that means you are going to have 4 mathematical expressions. If you have 5 suppliers, you are going to have 5 mathematical expressions for the supply capacity constraint. Then we do the same thing for the cities, which are the customers. And how do we do that? We also do the network, meaning that the way you do that one now is not difficult. Please listen. It means that what city 1 would get from any of these plants should not exceed what they require. English. What city 1 will get from any of these suppliers, which is P1, P2, and P3, should not exceed that 45 million they require. Meaning that if you look at your network, hence the reason why you draw the network, it means that city 1 will be supplied by either P1 or P2 or P3, meaning that what they are getting is X11 for P1 to C1 plus P2 to C1. If it's going to supply C1 is X21, and if P3 is supplying C1 is X31. Meaning that X11 plus X21 plus X31, meaning that everything that this C1 is getting from either P1 or P2 or P3 should be exactly what the city require, because the city wants 45 million. So it must be the same as the amount. Anything they are getting from P1 and P2 and P3 should be equal to that 45 million exactly, because that's their demand. So that's the reason why when we say it should be equal to 45 million, that means when we write the mathematical expression, it will be equal to. So if I write that mathematically, that is X11 plus X21 plus X31 should be equal to 45. So let me copy this and just edit. X11 plus X21 plus X31 equal to, that one will be equal to, why are we using equal to? Because we want to meet that demand exactly. The demand required, we want to meet it exactly. So that is how we meet that, and that will be equal to 45. Then the second one, we're almost there, is because we are doing it for the first time, is not difficult. We copy, then we paste it. What CT2 we get based on the network, if we go here, it means that anything P1 or P2 or P3 will supply CT2 should be exactly, when we sum it together, it should be exactly that 20 million. And that will give us X12, if you look at the network, X12 plus X22 plus X32. X12 you see is from P1 to C2 plus X22, which is P2 to C2, plus X32, which is P3 to C2. Should be exactly equal to what? 20 million. So let's go and write that one. X12 plus X22. If you have question, please ask. Plus X32 should be exactly equal to 20 million, which is equal to 20. We said that is a million already. And we are using equal to because you want to meet that demand exactly. Then we do the same thing for city 3 demand to meet their demand, meaning that we are dealing with X13 following the same principle plus X23 plus X33. X13 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 plus X23 plus X33 should be exactly equal to the demand for CT3, which is 30 million. So that will give me equal to 30. Then the last one, we are now there. I know some people already left. It's because I'm explaining, but if you do it and you have understand the concept, it won't take time. So the last one, which is CT4 demand, is X14, following the same principle. X14 plus X24 plus X34 equal to 30 million. X14 plus X24 plus X34 equal to 30 million. So those are our what do you call it? The demand constraint from the cities. And you see the supply constraints are these three because we have 3 suppliers. And I told you how we are writing that. If there are 5 suppliers, you have 5 mathematical expression in this format. And if in this case we have 4 customers, so we have 4 mathematical equation in this format. If there are more than 4, you have more expression. If there are 5, you must have 5 mathematical expression of equal to like this. So that's how we write this. Does this make sense? Let me quickly check. Type Y on the chat window if this makes sense. Please just confirm because we have only the last step. Sakiwe, please just respond. I want other people that are there to respond. Mashlango, Polen, Sukazi from your side. I hope it makes sense. We are only left with the last step now. Thank you. So let's do the last step, then we call it a day. Then I show you one exercise to do so that you master it, then we call it a day. The last thing which you need to do now is you need to write the non-negativity constraint. And what is the non-negativity constraint saying? It means that anything you supply from the plant to the city should, is it that you supply something or you supply nothing? It cannot be negative. If you look at the network, meaning that if I'm going to supply plant 1 to city 1, is that I supplying something or I don't supply anything? But I cannot supply negative. And the reason why you are writing the non-negativity constraint is that so that when we solve the mathematical model for this transportation problem, when we solve it, we are restricting our solution to always be positive or zeros. It can be negative because we cannot supply negative electricity. So it doesn't make sense. And the reason why you have to write your non-negativity constraint for any transportation problem. That will be the last thing for any transportation problem you formulate. And that is where you say your Xij should be greater than or equal to 0. Where your I equal to 1, 2, 3. Your Xij should be greater than or equal to 0. And you know, we said we've defined I is, instead of saying x11, x12, then you can just write it like this because we have defined what I is, 1, 2, 3, and j is 1, 2, 3, 4. So we know that xij is a number of unknown variables. So, and that will be the end of the formulation. And that's how you end. So actually your final linear programming model, we are done now, is this. Where we are saying minimize cost, which is the mathematical expression that I show you, that long expression that I show you how to do and we showed you in the textbook, subject to this set of constraints and the non-negativity constraint. So for any problem, you have to have something like this, depending on how many suppliers and how many customers are there in the transshipment problem given that scenario. So if that makes sense to you, please type Y. And let me quickly, maybe before you do that, let me show you the final expression of what we have done now in the note. You also see it in the, now in the, what do you call it? Thank you. Just to show you in the textbook. Thank you very much for the response. So we are done. I will just quickly show you the textbook and show you the final expression, which also talks to what we obtained. So you can see this is their final LP model, which was this objective function, which I showed you. You must have this. Then this ST is subject to. You remember we formulated 3 supplier capacity constraints. So we have that. Then this was also their network diagram that they were using to formulate, which we have also shown you. Then in this case, in their own case, they were using greater than or equal to as their demand constraint. But our advice, greater than or equal to, is not always a good, because we want to meet the demand exactly. So for me, I always advise let's use equal to, because we don't want to supply more than what the customer wants. Let's supply exactly what they want. Hence, for me, all these must be equal to, like what I did in the notes that I shared. So all these, where they are writing greater than or equal to, it must be equal to, so that we don't oversupply. And this is the non-negativity constraint, where I equal to 1, 2, 3, 4, and J equal to 1, 2, 3, 4. Where I is 1, 2, 3, and J equal to 1, 2, 3, 4, like we defined in the note that I was sharing. So that is that on this example. So if you understand it, please confirm by typing Y, then I will show you an exercise to do, then we are leaving. So are we all sharp? Sakiwe, please respond. Mashlango, Polen. Okay, thank you. Good. So please, just to practice, try this question at home. I will just give you one question, but I will give you more questions next week, but just to practice, just to keep you going, so that you know you have mastered what we have done today. So what you are going to do with this problem I'm giving you, which is question number 1, if you go to the ebook that I uploaded on Moodle, go to page 371. Let's do question number 1, just to see whether we have mastered the concept. So you see, what I want you to do with this problem, don't forget we have not solved. You must just do the same question that we did in the class, which is to formulate a linear programming model for that transportation problem given this scenario for question 1. So the question is formulate a linear programming model just like what we did for this transportation problem. And you must be able to get something similar to what we got in this exercise that we just concluded. So try it at home, and you can share your solution, send your solution to me via email, then I will check and see if they are correct or see if you have any mistake somewhere and advise accordingly. So I think with this, let's call it a day. You can see it's a long day, but I think it's because it's the first exercise and it's the first concept. So I want to take it slowly, then you understand it. So I think with that being said, since we are all happy, let's call it a day. Thank you very much for joining and for the patient. Then I would also upload the link for the recorded class session so that you can also have access if you want to replay and see what we did. Thank you. Have a nice evening. Bye for now.
Thank you.
Thank you, Sakiwe. Thank you. And also, please let me also say this. I know with mathematics, it takes time. So we always use the old time. So take note of that. So make sure even if you have something to eat, you can have something to eat, which is very light by your side and you are listening. So thank you very much. Have a nice evening. Bye for now. Bye-bye. See you next week, same time.
Bye.
Thank you. Bye-bye.